फाइन। सो लास्ट क्लास में हम क्लास डिज़ाइन पर बात कर रहे थे एंड दिस class design we are going for this recursive downward thing. So in this recursive downward, what we are trying to do is that we like to organize our different types of operations that has been identified and identified as an intermediate operation, and that are associated with your some classes, and these operation are supposed to be the internal operations. These are not directly attached to your any of the particular users or the behavior of user, but it is an internal behavior of our system. Like हमने जैसे भी बात करी थी कि हमने कौन से एग्जाम्पल में बात करी थी, हाँ सेशन मैनेजमेंट वाले पे बात करी थी। सेशन मैनेजमेंट के साथ जो कुकीज़ आ रही थी, कुकीज़ डिलीट करनी थी वगैरह एंड सो ऑन. सो these are different internal operations, and depending on all those internal operations we have to organize our operation as a layer. So in the previous classes we had identified that what are the internal classes that can be invented during your class design phase for the sake of for the good class design or for the easy implementation view. And then we had identified some operations that are not belong to any real world cases, but that may be analogous or may not be analogous. So हमारे पास बाय डिफ़ॉल्ट तरीका ये होता है कि अगर हमारे पास एनालॉगस रियल वर्ड से एनालॉगस है तो हम उसको उसके रिलेटेड क्लास में आइडेंटिफाई कर लेते थे। अगर वैसा नहीं होता था तो हम उसका फॉर टारगेट एक्शन पे बात कर रहे थे, उसकी जो टारगेट क्लास थी या उसकी जो फोकल क्लास थी उसमें हम उनको आइडेंटिफाई कर लेते हैं। देन after identifying all those, then we have to organize all those operation as a layer, because हम हमारे पास जो classes हैं, classes पे भी हम layered architecture बनाएंगे. So we have to organize all those operation as a layer. So we are having two ways: either we can go for your functionality layers, or we should start with your mechanism layer. So in this functionality layer is supposed to be the natural way. हमारे पास जो higher level of operations थे, high level of, or usually we are selecting this recursing downwards. Why we are recursing downwards? Because हमारे पास two approaches थी. Either we can go for top down approach or we can go for bottom approach. और हमने देखा भी था कि bottom approach के साथ एक दिक्कत आ रही थी कि हमारे पास irrelevant and unnecessary operations भी identify हो रही थी. This might be enriched and it takes much time to it takes an extra time. So this is an risk. So we are going for downwards. Like हमने high level of operations identify करे, फिर उनके छोटे छोटे सब parts में या सब routines identify करते गए natural way में गए. Then उसमें भी हमारे पास दो तरीके थे. Either we can go for either by functionality or by the mechanism. So basing on the functionality, what we are trying to do is that we'll take an higher level functionality and then break all those into the lower lesser operations. जैसे हमारे पास बहुत सारा काम था, हमको लॉगिन करना था. अब उस लॉगिन में हम पहले ये भी चेक कर सकते थे कि प्रीवियस लॉगिन था या नहीं था. अगर लॉगिन हो गया है तो हमको क्या करना. सो दिस आर हाईएस्ट ऑपरेशन. तो उसमें हम छोटे छोटे ऑपरेशंस में हम ब्रेक कर सकते थे. एंड दिस इज सपोज टू बी द नेचुरल वे ऑफ इम्प्लीमेंटिंग योर recursive downwards, or even you are organizing your operations. Now the second way is mechanism layer. So what is this mechanism layer? So this particular mechanism layer, it means that you are building your system out of layers of needed support, that needed support for mechanism. मतलब हम क्या बोल सकते हैं. So what we are trying to do is that when we are going some, like say we are providing functionality, so we need various mechanisms to store our information. Like we go for a sequence control, or we can coordinate our objects, or we can transmit our information, or we can perform computations, or we can provide other kinds of infrastructure for all those operations. So this type of mechanism, like coordinating your objects, or the sequence controls, or transmit information, so this type of mechanism don't show explicitly in your high level of responsibility or high level of operations, but this must be needed for your system to function well. So let's say again, let's say we are constructing an tall building, let's say we are constructing a tall building and we just need an infrastructure to support our girders and some utilities or building control devices and so on. So these are not supposed to be the functional requirements. let's say हम बहुत बड़ी बिल्डिंग बना रहे हैं और उस बड़ी बिल्डिंग में हमारे पास हम पहले एक फ्रेम आयरन स्टील का फ्रेम स्ट्रक्चर बना रहे हैं और उस फ्रेम स्ट्रक्चर के साथ हम मकान बनाने या बिल्डिंग बनाने में सारी हाई राइज बनाने की सारी चीज़ें कर रहे हैं। पर उसके साथ एडिशनली हमारे पास क्या चीज़ें आ रही हैं, हमारे पास एडिशनली चीज़ें आ रही हैं कि हम जब मकान बना रहे हैं तो हमारी लेट से हम गर्डर्स डाल रहे हैं, हम वो स्टील का आर्किटेक्चर बना रहे हैं, तो स्टील का आर्किटेक्चर हम कैसे आगे बढ़ें, हम क्या पूरा स्ट्रक्चर मतलब क्या पूरा बेस एक एक हम क्या बोल सकते हैं, एक एक फ्लोर पर आगे काम करते जाएं, एक फ्लोर कंप्लीट करा, दूसरा फ्लोर कंप्लीट करा, तीसरा फ्लोर कंप्लीट करा, चौथा फ्लोर कंप्लीट करा, ऐसे काम करते जाएं, या सिंपल आप पहले फर्स्ट फ्लोर का, सेकंड फ्लोर, थर्ड फ्लोर का गार्डर्स या स्टील कंप्लीट करें और उसके बाद आप आपकी ब्रिक्स लगाना चालू करें। सो दीज आर डिफरेंट टाइप्स, we are having different types of mechanisms that are being available. So for that scenario we have to consider uh, all those things, like we are going for, let's say, computing architecture in our information system. So we are having different types of things, like we can use different types of data structure. This is considered an mechanism. Then we have different types of algorithms or control patterns. Let's say uh, मुझको सर्चिंग करना है किसी वर्ड में, तो आइदर वी कैन गो फॉर some very good searching algorithms, or we can have some parallel algorithms or parallel implementation of algorithms. So this is supposed to be another way of finding your particular seed word more faster. Or we can go for different types of data structures that we had covered in the earlier classes, like again when we are looking for something, so either we can go for your let's say we are some numerical values over there, so either we can go for sequential search, or we can go for binary search, or we can store our data. So what is the faster way of retrieving our data, or how to identify your duplicate entries in a particular list. So this is how we can go for, or we can say that let's say uh, we are having a sequence in our Python, and that for that particular sequence we have two types of sequence, like some things, someone are immutable and some sequences are considered to be the mutable. So for all those sequences we have uh, these sequences are have some different way of uh, implementation, or let's say mechanism. like हमको जब पैरामीटर्स में पास करना था, तो हमारा ओरिजिनल पैरामीटर कितना चेंज हो रहा है, मतलब हम एक फंक्शंस डिफाइन कर रहे हैं, और फंक्शन डिफाइन करने के बाद हम या तो लिस्ट प्रोवाइड करेंगे या हम उसमें टपल प्रोवाइड करेंगे, तो आपके पास डिफरेंट मैकेनिज्म अवेलेबल हो रहे हैं। अगर मेरे पास मैं टपल प्रोवाइड कर रहा हूँ, तो मेरा फाइनली जो अपडेटेड डेटा है उस लिस्ट में, उस टपल में रिफ्लेक्ट नहीं होगा, चेंजेस रिफ्लेक्ट नहीं होंगे। वाइल मैंने अगर सीक्वेंस में लिस्ट भेजी है, तो मैंने जो अपडेट उस पर्टिकुलर लिस्ट में करा था वो मेरी फाइनल ग्लोबल लिस्ट में भी अपडेट होगा। सो दिस इज हाउ वी कैन अचीव डिफरेंट टाइप्स ऑफ mechanism in our system. So it solely depends on your particular application domain, but they are again associated with your particular software architectural style. So again, let's say uh, uh, let's say we have a subject view pattern that associate many views with your e subject object. So uh, again, let's say this is OAD subject. So this OAD subjects, we are having different views available and we are having different patterns available. Let's say हम simple से view की बात करते हैं. Once someone suppose that this is a theoretical subject, someone suppose that this is the advanced type of the software engineering. Someone says that yeah, this is the older fashion of software construction because we are moving towards DevOps. So we are having three different views for this particular subject. So fine. So for each particular view we are having some different types of semantic information available. Let's say when someone says that and this is supposed to be the more advanced than your particular software engineering that you had covered in your either fifth or sixth semester. So the semantic information that is related to that particular subject is that like you are going to get something new knowledge. Then someone says that it is an again an theoretical subject, so someone says that this is an boring subject and I do not like to attend all those classes. Fine. Then someone says that yeah, this is again an boring subject, or we can say that this is an older fashion subject and we like to move on DevOps. So again, so the semantic information related to that particular subject is like this is an old fashioned subject and we are that university is forcing to learn this subject, but we are not at all have this interest in that particular subject because this is a very old fashioned. So we can say that we are having semantic information with particular semantic view for all those things. So as a piece of software, when we are trying to go like for mechanism layer, so we are having more primitive mechanisms that are being available. So let's say uh, you are having some large system that contains mixed functionalities and mechanism layer. So let's say a system is designed entirely with your functionality recursion, and then we are having some requirements. That requirement make some changes in your particular application, so your system design now shifted to work on your this mechanism layers. So these are different, we are having different ways. Either we can go for functionality or we can go for our particular mechanism. So let's say again consider an example. Let's say we are going for an ATM examples. So for a particular ATM, either we can go for functionalities or we can go for this mechanism layer. So we need both. Let's say we are having some communication devices associated with your ATM, and then we are having some distribution infrastructure or distributed infrastructure available. So when we are saying that distributed architecture, it means that we are having a bank and different ATM computers are installed on your different locations, and they like to communicate more efficiently and more quickly with each other. So we need some architecture that must be resistant to it, resistance to provide resistance to your errors, and that make some communication fast. So what we can do is that we can go for both the combination of mechanism layer as well as your functionalities. Either we can go downwards with a higher level of implement, high level of operations, and then lower layer of operations. In addition to that, we can identify different mechanism to identify all those through. So what we can do is that we can achieve all those things at a time. Fine. So इसमें कोई problem?
No, sir.
No, sir.
Thank you. Then the next thing is refactoring. Fine. So what is this refactoring? So when we had started with our initial analysis, then we had started with the initial system design or then system design, and then we are moving towards final design, let's say in class design, that are much more focusing on the how things to be carried out. So when we are moving in the when we are in the initial design, so your initial design includes a set of operation that will contains your inconsistency, redundancy, and inefficiency. And this is supposed to be natural because we are in the initial phases, and your operations may be inconsistent, redundant, or inefficient. And in final class design, we are making lots of efforts to find out what are the good operations, what are the good classes, and how we can associate operations with your classes. So the initial design that contains a set of operations are supposed to be the inconsistent or inefficient or and redundant, and this is supposed to be the natural because it is impossible for us to get a large design that is correct in your initial pass or in the first pass or in the two passes. So हम पहले पास या दो पास में तो हम exactly correct design बना भी नहीं सकते, और exactly हम हमारे practical में भी यही था कि हमने domain classes identify करी थी और domain classes को हमने फिर refine करा था एक दो phases में, और मैंने तीसरे practical में भी आपको यही दिया है कि आप again आपके domain classes को refine करते जाएं, और finally हम जब सारे implementation पर जाएंगे तो आपके पास में हर बार आपकी डोमेन क्लासेस को रिफाइन करूंगा. सो वी आर आई एम सपोज दैट यर the initial design is inconsistent. I am not saying that it is wrong, but yeah, it is inconsistent, it is redundant, and it is inefficient. So we'll start with our basic assumption, and then we'll like to match our assumptions or our experience with your client requirements. So we have to take some decisions. So these decisions are linked to either linked to other decisions of other person, or like your client decisions and so on. So it doesn't matter in which order we make decision, but not all, but some of the decisions must be optimal. Why? Because we have to create a software that must be we must optimize their computations and so on. So we should go for some optimal design, and it doesn't matter what are the uh, order of making decisions. Fine. कि हम पहले लेट्स से लॉगिन के लिए बात कर लें, फिर रजिस्ट्रेशन के लिए बात करें, तो आपके सिस्टम में पहले हम रजिस्ट्रेशन पर बात करते हैं, फिर लॉगिन पर बात करते हैं. यहाँ आपको डिसीजन मेकिंग पे कोई फर्क नहीं पड़ता. हाँ, हमारी चीज़ें होनी चाहिए, ऑप्टिमल होनी चाहिए. इन एडिशन टू दैट, as our design evolves, it also degrades. So what is the solution? So the solution that we suppose that it is good to use an operation or a particular class for multiple purposes, like an operation or the class that considered for one purpose, one particular purpose will, it should not fully fit in your particular domain or application domain, or we can say that it do not fit for some additional purposes, like we want to make some scalability in our system. So a class that is made only for a particular purpose, so the scalability is something compromised over there. So we must revisit our design, and we must rework all the classes and all the operations so that they should cleanly satisfy uh, their usage, their functionalities, and what are the basic concepts for defining all those classes. If we are not doing so, then our application will become like, it will become difficult to understand, it will become brittle, or we have some awkward condition to extend or maintain our classes, or we can say that it will eventually collapse uh, our system design. So what we are trying to do is that we like to use our classes and operations like uh, in multi-purpose way. Fine. So we have the solution that is known as refactoring. So refactoring is supposed to be defined as a change to your particular internal structure of your software to improve its design without altering its external functionality. Again, we are saying that it is defined as a changes to your internal structure of your software to improve its design without altering its external functionality. So it means that we step back, then look across where we are having different classes and different operation, and we like to reorganize all those operations and classes to support uh, further development, and uh, it is supposed to be done for your better performance. Fine. So refactoring may seem like some says that it may look like an waste of time, but it is an essential part of your good software engineering process. So uh, And again, it is not enough for us to deliver functionalities without refactoring all those things. If we expect to maintain our design, then we must keep our design clean, or we can have some modular design, or we can have some understandable design. So refactoring keeps your design viable for your continuous development. So when we are going for this continuous development, or when we like to move for the scalability, so your refactoring is supposed to be the good thing for our system. So it is the refactoring is just suppose that we expect some more opportunities for uh, adding some operations, or adding some additional use cases, or adding some functionalities to your system. So this refactoring provides some way how you can go for implementation, all those things. Fine. Then the next part is design optimization. So I'm moving towards design optimization. So in case of design optimization, so we'll start again. We had worked on like refactoring. So when we are in the refactoring, we are saying that we like to make our system optimal, or at least we need some operations that are suboptimal. So the next consideration is supposed to be the optimized design of our system. So when we are designing a system, so a good way to design a system is to first get our logic correct. That is, we suppose that our logic should be correct, then we like to optimize it. Like for an example, we like to create uh, again a Fibonacci series program. So फर्स्ट थिंग इज दैट कि हमको जो लास्ट टू टर्म्स थी उन लास्ट टू टर्म्स को ऐड करना है, तो हमारा जो असाइनमेंट था वो असाइनमेंट हमारा गलत नहीं होना चाहिए. सो फर्स्ट वे इज दैट यू शुड गो फॉर करेक्ट डिजाइन, एंड देन वी लाइक टू ऑप्टिमाइज. सो व्हाट इज द वे ऑफ ऑप्टिमाइजिंग इज दैट we should go that say a0 and a1 should always be your 0 and 1. Or when we are going for this factorial program, so when we are going for this particular factorial program, so we suppose that when you are having a number that is less than 0, so will return a bad value. Or when we are having some value like 0, so will return again 1, and we are having again a value 1, so we'll again go for uh, will return a 1 or 2 for 2, again for 2 we again return 2, instead of calculating like 2 into 1. So it takes your continuous loop. So when we are going for this optimization way, so we should initially go for correct logic, and then we'll go for optimizing. So like again, when we are having different types of loops, so how we can optimize all those loops. So this is a way how we can go for optimization. So when we are going for optimization, so it is supposed to be the difficult to optimize a design that we had created, because we suppose that we had created some design, and this is supposed to be very good in our view. In addition to that, we can say that a premature concern with the efficiency often leads to the contorted and the inferior designs. So once we have some logic in place, then we can run our application, and then we'll measure its performance, and then we'll like to fine tune it. So again, just let's take an example like an like again your gradient searches or gradient based optimization. So we'll start with some basic and our initial assumptions, and then we like to fine tune our performance with your hyperparameter tuning and so on. So this is a different way, and this is not a different way, this is again supposed to be a same way. Like we'll run our application, we suppose that its output should be correct, and then once we get the correct output, and then we like to fine tune all those applications. So often a small part of the code is usually responsible for the most of time, and it takes much more cost. क्योंकि हमारे पास बहुत बड़ा प्रोग्राम होता है, उसमें से हमारा एक लूप है जो कंटिन्यूसली चलता रहता है. अदरवाइज पूरे प्रोग्राम में कई बार ऐसा कोड होता है जहाँ पर हम कई बार पहुंच भी नहीं पाते. सो आर फोकस ऑन so it is better to focus the optimization on such critical areas than than to spread our efforts evenly on all those codes, because हर कोड हमारा इतना टाइम लेना भी नहीं है. फाइन. सो इसका मतलब ये भी नहीं है कि हम पूरा ऑप्टिमाइजेशन जो है, या अदर वी कैन से दैट वी टोटली इग्नोर द एफिशिएंसी ऑफ आवर इनिशियल डिजाइन. सम अप्रोचेस आर सपोज टू बी मोर ऑब्वियस for your inefficient design that we should not consider for implementing. So if there is a clean and simple and efficient way to design something, then we'll use it. But we don't do something that's supposed to be a complicated or supposed to be the unnatural way, because हमको नहीं पता कि वो कॉम्प्लिकेटेड, तो हम मानेंगे ही कि कम से कम वो हमारा परफॉर्मेंस डिग्रेड करेगा. हमारे पास कोई अननेचुरल वे आया, हमको नहीं पता, हमने उसको कभी यूज करा ही नहीं है, तो हम ये नहीं कह सकते कि वो परफॉर्मेंस इंप्रूव करेगा. दिस इज जस्ट एन गैम्बल. फाइन. सो what we are trying to do is that first we like to clean our design, then we like to optimize it, and then we may find our concern that was misplaced in our system design. So our design models builds on our these design models usually builds on analysis model. Not usually, it of course it builds on your analysis model. So your analysis model captures your logic of your system, then our design model focuses on your development details, and then we'll go for implementation. So we can optimize the inefficiency during our these design classes. So we are having three different tasks available for your design optimization. First is to provide efficient access path to our system, then we'll go for rearranging the computation for your greater efficiency, and then finally we'll go for save intermediate results, provide some recomputations and so on. So I would like to start with adding redundancy, like provide efficient paths. So for this providing efficient access path, well, I like to go with your adding redundant association for your efficient access. So when we are saying that we are adding some redundant association for efficient access, but these redundant associations are usually undesirable during our analysis phase, because it does not add any additional information to our system. But when we are considering, let's say, in our design, it has very different motivations, and it should focus on the viability of uh, your model, well, for their implementation. Fine. So what if we are having different motivation associated with adding some redundant association? So like we can have, like, can this association be rearranged to optimize your critical aspects of your system, or we can have should we should new association can be added, or can we go for can existing association to be omitted? So this association right from your analysis phase may not uh, form your efficient network, but when we are considering them as an pattern, or we can say that we can have some access patterns, or we can have some relevant frequency, then we can say that we can add some redundant association with our example. So consider this example, this first example. So we are in a design of companies uh, employee skill database. So we are having company, then a person, and then a skill. So a company has many employees, or a company employs many persons, and many person works in your company, then a person has many skills, and so on. And a skill can be available in the many persons. So this is my initial class design. So when we are going, like we have some function like find skills of your particular person. So this find skill is associated with is associated with like I like to find a skill. So find a skill should be targeted toward your company. So fine. So I like to call this company dot find a skill. So it returns a set of person. Again, when we are saying that find a skill, so find a skill, it means that for particular skill, uh, it will return multiple persons. So it means that it will return a function. So this function will available in the company classes, and it will return a set of persons or a list of persons with particular given skills. So let's say uh, इंडियन तो आती है, लेट्स से an application might need all the employees who can speak Japanese language available, Japanese language. So for this example, let's say suppose a company has near about 1,000 employees, and each of whom has at least 10 skills available on an average. So what we can do is that we can have some nested loop that traverse or your uh, employees 1,000 times, and then we have some has skills available. So this is my has skills. So we have some has skills. Let's say 10,000 times, because we are having 1,000 employees, and on an average each one has 10 skills. So on this way we can say that we are iterating over 1,000 times or 10,000 times. And if we are having only fine let's say 5 or 10 employees actually who can actually speak Japanese, then uh, let's say again we considering this, let's say 5. So uh, सिर्फ 5 लोग ही जापानीज बोल रहे हैं, तो लेट्स से वी आर हैविंग our test to hit ratio is we are having 10,000 iterations and we'll find only 5%. So it means that our hit ratio is like 2,000 available over here. So we can say that we are having several improvement that are being possible for this example. Let's say first we can use some hash set for our employees, because when we are looking for uh, let's say who speaks Japanese, so instead of having some unordered list, we are searching for 10,000 times, we can have some hash list, and for this particular hash list we can find a person very easily. So an operation can perform uh, hashing at the particular constant time, and then so mm, so the cost of finding a person who speaks Japanese is supposed to be the constant when we are having a constant a function that makes some hashing for finding skills. So we are having a hash function that works on uh, constant time, and then we like to find on this, so we again having some constant time. So what we are trying to do is that we are just having 10,000 iterations just for your unordered list, then we'll like to move for some constant function. If we are having let's say 50,000 employees, then again it makes much more computational cost. So but when we make some this like hash function, so for this particular hash function we are having a constant time instead of it has been dependent on particular number of employees in your person. So what we can do is that uh, in these cases, like when we are like going for hash function, so this number of hits are supposed to be very low, and again we can make indexes again when we are having some like hash function, and in addition to hash function can we make some indexes. So this index contains all those items who are frequently retrieved, or this is supposed to be like your cache memory in your system. So okay, and uh, so when we are considering this, let's say again consider this example. So what we can do is that we can have some hash function, or we can have some indexes. So like we can add some association language. So we have some derived association, like we are having some company that contain that has many persons who speaks then some languages, and on these languages we can have some speak languages right from your company to your persons, where qualifier is supposed to be your language spoken, like Hindi or Japanese and so on. So this derived association that is being available here, so this derived association does not add any information, but yes, it permits to fast access your uh, fast retrieval of your system for a particular language. So although when we are going to create this indexes, it requires some cost for creating index, but this cost is let's say supposed to be very minimal, because this index is being created only once. But when we are like to search all those persons, so it may be, it may take, like again we are having, let's say 1,000 people, so it may go for 10,000 times uh, only for one search, and let's say we are searching 1,000 times, so it may take much more time. So what we are trying to do is that we like to add some redundant association for your efficient access, because it does not add any important information available here, but it supports for better access or efficient access of let's say again searching for something. So this is all for today's class, and then we'll go some criteria for adding this redundant information, and then uh, within 2 or 3 days we like to complete our syllabus. Fine. So this is all for my side, and if you are having any questions, then you can ask